Welcome back to session 16 of GED Advanced Graphs and Functions. Today we meet quadratics, functions with an x-squared term that graph as a smooth U-shaped curve called a parabola. We will learn to recognize them from an equation, from a graph, and from a clever pattern hidden in a table. Let's take it slowly. The signature of a quadratic is an x-squared term. That squared term is what bends the graph into a curve instead of a straight line. A linear function, like 2x plus 1, graphs as a line, but a quadratic, like x squared minus 4, graphs as a parabola, a smooth U shape that opens up or down. The x squared is the key. A parabola is a smooth, symmetric U. If the x squared term is positive, the U opens upward and has a lowest point. If it is negative, the U opens downward and has a highest point. Either way, the curve is perfectly symmetric. The left half mirrors the right half around a center line. Let's see one. Here is a beautiful way to spot a quadratic in a table. First, find the first differences, the change in y from row to row. Then find the second differences, the change in those changes. If the second differences are constant, the pattern is quadratic. A line has constant first differences. A parabola has constant second differences. Let's test the table 1, 4, 9, 16 for x equals 0, 1, 2, 3. Step 1, find the first differences. 4 minus 1 is 3. 9 minus 4 is 5. 16 minus 9 is 7. So the first differences are 3, 5, and 7. They are not constant, so it isn't linear. Let's go one level deeper. Step 2, find the second differences, the changes in 3, 5, 7. 5 minus 3 is 2. 7 minus 5 is 2. So the second differences are 2 and 2, perfectly constant. Because the second differences are constant, this pattern is quadratic. The answer is yes, it's a quadratic. Quadratics also have a friendly vertex form. Y equals, open paren, x minus h, close paren, squared plus k. Just like absolute value, the vertex is the point h, k. The h sits inside and flips its sign. The k sits outside and keeps its sign. The vertex is the tip of the parabola, its lowest or highest point. 3 traps. First, do not call every curved graph exponential. A symmetric U-shape is a parabola, not exponential. Second, do not stop at first differences. You often need the second differences to confirm a quadratic. Third, always put negative inputs in parentheses before squaring, so the sign is right. Careful checks win. Let's lock it in. A quadratic has an x-squared term and graphs as a parabola, a symmetric U that opens up or down. In a table, constant second differences reveal a quadratic. And vertex form, x minus h squared plus k, hands you the vertex, h, k. Now, parabolas are easy to spot. Wonderful work today. You can now recognize a quadratic from an equation, a graph, or a table. Your mastery check is the 10 practice questions for this session. For each one, check the second differences or look for the x-squared term. To read the full lesson notes and practice more GED graphs and functions questions, visit the course page at www.bridgetoexam.com. I will see you in session 17, where we find the vertex, roots, and intercepts of a parabola. Keep going. You are doing great.